Hello everyone, this is a product demo video of Dyna TnIT, Transducer and Instrumentation Trainer, which is manufactured by Dynalog India Limited. So we will be talking about Dyna TnIT. It itself is a contained transducer and instrumentation trainer which provides example for full range of input and output transducers, signal conditioning circuits and display devices to illustrate its characteristics and application. The purpose of this video is to give you a brief overview on Dyna TnIT and to show you how easy it is to operate and run the kit. Let us see what we get when we unpack the kit. A main unit of Dyna TnIT, colorful 2mm patch cords that will be used to make the connections on Dyna TnIT trainer, a power cord to connect the Dyna TnIT to the main power supply, a digital multimeter for observing and measuring the outputs at various units of TnIT, a user as well as technical manuals for your ready reference. This is a transducer and instrumentation trainer which is enclosed in a mild steel enclosure with inbuilt power supply. On the left hand side of the kit, you could see a fan which is used for heat dissipation purpose. Similarly, there is one more fan on the right hand side for heat dissipation purpose. Coming towards the back side of the kit, this is a power supply section with 3-pin male power socket where you need to connect the power cord and a switch to power on the device once you connect the power cord to the kit. Dyna TnIT can be further classified into 4 sections, namely power supply section, input transducers section, signal conditioning section, and your output transducers and actuators. At the bottom of the board is the power supply section. This power supply section consists of plus 5 volt, minus 5 volt, plus 12 volt, minus 12 volt with all ground pins common to it, along with the 3.5 ampere current rating. This section is used to provide different voltage to perform various experiments. Next, we move towards the input transducer section, under which there are various potentiometers like rotatory potentiometer, which are of wire wound, carbon track, slide variable potentiometer, and a precision 10-turn potentiometer in a Whetstone bridge circuit. In this potentiometer, you can see the number of rotation which maximum goes up to 10. Next, we move on into temperature sensor section, which is equipped with different type of sensors. The active transducers are mounted within a clear plastic enclosure along with the heater, that is 33 ohms 10 watt cement resistor. The heated enclosure is provided to raise the temperature of a sensor transducer to allow measurement to be taken during experiments. It consists of 2 NTC thermistor 4.7 kilo ohm, a platinum RTDP T100, a K-type thermocouple, and a LM35 temperature sensor. For NTC thermistor, the change in temperature is inversely proportional to the change in resistance, while the other 3 sensors have direct relations between temperature and resistance. Further, we move on to the optosensor section. These optosensors are contained within a clear plastic enclosure and can be eliminated by a lamp which is placed centrally. The optosensor section has 4 sensors mounted on it, namely photoconductive cell, a phototransistor, photovoltaic cell, and PIN diode. Among this sensor, the photoconductive and a phototransistor have an output that is inversely proportional to the change in luminosity of light, while the other 2 have a direct proportionality. Further, we move on to mechatronics section, which consists of various mechanical transducers. This section consists of LVDT and strain gauge that converts displacement and pressure into equivalent electrical output. It also contains a DC motor with an array of discs on a spindle that are used to demonstrate the various sensors like slotted optosensor, reflective optosensors, inductive sensors, Hall effect sensors, servo potentiometer, and a tacho generator. Let us come towards the LVDT section. Linear variable differential transformer. It consists of 3 coils. The middle coil is a primary winding and the remaining 2 coils are your secondary winding, having a magnetic core that is movable within the coil. Turns per coil for primary winding and secondary winding, it's 75 turns. Inductance per coil is 68 microhenry and a mechanical travel is up to 15 mm. This is a strain gauge. The gauge is connected in a wedge-stone bridge arrangement with the bridge balance under no load condition. So as we put a load over the strain gauge, the resistance varies, which could be observed on the multimeter. Next, we move on to the environmental sensors. This includes an airflow sensor, air pressure sensor, air valve and a humidity sensor. There is an inbuilt air pump which is used to perform the experiment of airflow sensor, air pressure sensor and an air valve. This is a SPDT switch in order to switch on or off the air pump, and a knob for the selection of airflow sensor and an air pressure sensor. Now coming towards the ultrasonic transmitter and receiver section. It is used for detecting the motion of an object at a 40 kHz frequency range. The other one would be our microphone section. A dynamic microphone operates on a principle that a magnet moved within a coil generates a voltage. In this case, the magnet is fixed and the coil is the moving part. The coil is attached to a thin diaphragm which moves in response to solenoid vibration of the air which is used in the input. Coming towards the output actuators and transducers, these are our loudspeaker and buzzer. Loudspeaker and buzzer are both output devices. The loudspeaker is fed by an alternating current between 50 to 1600 Hz and audible tone will be produced. And a 12 volt DC buzzer is used to create the sound or noise. These are our solenoid and relay section. This solenoid is a miniature pull-in type. The activator is soft iron core which moves inside high inductance coil. The operating coil voltage is of 12 volt. For this relay, it's a common terminal which is attached to a spring contact strip. Coil operating voltage is also of a 12 volt. Coming towards the display devices, this section can be used to observe three different parameters. First, to observe the time. Second, to count the pulse which is generated by a slotted opto sensor. Third, to measure the frequency and the speed of a DC motor. Coming towards the LED bar graph display, this LED bar graph display consists of 10 separate light emitting diodes fitted in a 20 pin package. The light from each diode is collected by a light pipe and appears at the top surface as a red bar. The dedicated IC driver chip controls the device and provision is made for adjusting the voltage level required for adjacent LEDs to light. With the device as fitted to the TnIT trainer, the voltage level between adjacent LED is 0.5 volt and hence the minimum voltage for all LEDs to light is plus 12 volt, which has been calibrated with the help of this 10K potentiometer. Coming towards the moving coil meter, which is used for measuring the voltage from minus 10 to plus 10 volts. Coming towards the fourth section, which is our signal conditioning unit, as they form the heart of almost every electronic circuit. This signal conditioning circuit contains various type of amplifiers, your 100x amplifier, the differential amplifier, instrumental amplifier, power amplifier, summing amplifier, current amplifier and your AC amplifier. It also has a 40 kHz oscillator, 40 kHz filter, a full wave rectifier, a sample and hold, an integrator, a low pass filter and differentiator, along with the electronic switch. And then we do also have a comparator, alarm oscillator, along with voltage to current converter and current to voltage converter. We also do have a voltage to frequency and frequency to voltage converter also. If you need more further information regarding Dyna TnIT trainer, please do refer our technical manual or you can refer our website which is www.dynalogindia.com.